check if it's working?
Let's see.
Just go to Twitch.
Dr. Nekoma. And okay, apparently it is. So hello, people from the future.
No. But I change. It is working right now.
Yes, it is.
Okay. Okay, guys. So let's go. Am I in the correct branch though? FFI and pagination. Yes, I am. Ooh. What do we have in here? That's interesting. I don't know if you care about that. Yeah. I don't know if I care about that either. That we care, and that we don't care. So that stuff. Uh, I actually think we don't care actually. Let's just start by actually changing the C implementation. I think that's easier. So I don't know if you remember, but you're gonna have to update the the C implementation. We're gonna have to update the C implementation. So where the fuck it is? That's um that's an interesting question. Add projection. That's not really what I want. Oh, it is in here. Cool. Let's grab it raw. Uh, so the first thing that we gotta do, oh, let's add the context to the recording as well. So after very long discussions about pagination, we discovered that to make that work generally, not only in the case that we implemented before, that was harder. So in order to fix that, we had to think about it and read a book called SQL Server. And it seems to me that we finally got it. At least that was the reaction that Magetta portrayed when when he implemented the first draft in F sharp. And now we are here to basically port that solution to Racket again and probably make it better because maybe he's not doing it across. Like I believe there is a step that he's not doing at the end. Uh, so that's what we're here for. That's what we're here for. I'm so glad the discussion on Tuesday was helpful, man. That was great.
It was good. Yes.
We learned. Like again, it is the best moments when you're doing something and you don't know how to proceed, and then you have to discuss about it, and you have to go to a reference implementation and understand it. That was great. That was great. And we may re-explain it here for recording purposes if as we go along the changes. We're gonna have to remember how to explain them because today we're gonna use the F sharp implementation as a reference implementation. Why the heck my these things require so much time? I guess I never did this again after I updated my system because I did update my system.
Patching Emacs 28.2.
Yeah, that's because we are requesting the flake that you have Emacs in order to use the eLisp service, a client service,
Oh,
client eLisp client. Yes, that's the thing. Because we have multiple clients. We have one in F sharp, one in Clojure, one in JavaScript, and one in Racket, and one in eLisp. All of them just communicating through a socket, which is kind of hilarious because I think we're gonna not implement the query language before the deadline, which is very sad, but well, it is what it is.
It is what it is.
OpenJDK. This is Clojure stuff now. That's cool. Well, while we wait, let's take a look in the F# implementation. So I think the solution was that we need to use global B plus 3. That was kind of
Yes, we
related
do.
to it. That was kind of related. Oh, we're also gonna have to do the iteration in with the pointers in Racket, man. I forgot about that. Um, because remember, Agita didn't want, for some reason, he didn't want to go with the other path that I described. So we're gonna have to cope with that, unfortunately. So what is okay? So just B plus. That's not what I want. That's also not what I want. Okay, so we created the library, the static linked library. But that's wrong because the FFI is not going to work. So we need to fix that. We need to fix that. And the way that Magita did it, he used this C record thingy. He used the C record thingy. We definitely should not do the pointer arithmetic crap in Racket though. Again, decisions, right?
Yeah.
Uh, I'm not a fan. Definitely not a fan. This is why we need void star in here. So let me explain. So after the discussions, it was very clear that once you do a search in a B plus tree, you're gonna find your thing and you're gonna loop over that because there may be more things that you are interested in, such as if you're looking for a key, like in year of 1999, the B plus tree will give you the location of the first one, but you know that the leaves are already sorted, so you need to walk through the pointer, in this case, this pointer. In order to do that, that's the part that I think Magita didn't generalize it, because he's just grabbing the first, I believe. He's not doing a loop over that until it's not what he's looking for. He's just grabbing the first one. Um, so in order to fix that, we need to do something about this void star, and we need to do a loop over that. We need to do a loop over that. And you know what's really fun? We're gonna have to do the jumps of the offsets based on a single, like, in a single record, as you call it, which is not fun because again, C is probably best suited for and tailored for these types of things. But my Geta didn't want to touch much of the C code, which again I think it was not it was not a good decision overall, but that's fine. It is not like it is impossible to do it. So I think the first thing that we gotta do, Marinho, is to fix this FFI. We needed a C struct. Unfortunately, and ironically enough, Racket does have a way that you can define a C struct, um, which is kind of interesting. C structs. Right. So how does it work? We know what we're gonna do is the following. We gotta go to the C code again. Oops, I was there. Yeah, here. So find and get value. Uh, is this the function that we want actually? Find and get value. This returns a record star. This returns a record star. And before we were using this function already in the F5, but this was returning an integer. This was returning an integer, and now it is returning a record. Right. So what we're gonna do is to search what the heck this record is. It is this. As you can see, it is a struct of three things. And what we're gonna do about that, we will add a C struct in here, like so. Uh, and we will mimic this thing in here. And we're gonna use that as the pointer. So this is gonna be something like a record. And then in here we're gonna have something like a chunk number, and this is gonna be an integer. Not anywhere there.
I am, and you misspelled number.
I misspelled number, of course. And we're also gonna have the slot number. The slot number. So it is really important to understand what this does. And basically, long story short, we are doing something called non-clustered indexing, right, Marin?
Yes, we are.
We are doing something called non-clustered indexing. That uses some sort of like a tuple, a triplet of composed out of three values, which is the chunk number, the page number, and the slot. And these are basically numbers that you're gonna use to look up onto some sort of like a location, right? Um, so the chunk number will tell you which chunk of the chunks that you sliced the thing that you're looking at is. And then each chunk is composed of multiple pages, and each page has multiple slots, let's say, that tells us where is the data that you need to care. What is the data that you need to care? In order to know how many data, given that location, how much data we need to read, we're going to use a schema. So that's cool. That's really cool. So, uh, theoretically, this should be it, right, Manu? This is exactly the same thing that Magetta did, but now we don't have to do the casting, because what took him so long was to discover how to do these three lines here. Because this is
I
void
see.
star, right? This is void star. And you need to provide a type in order to know how much value you're gonna like from which coordinate to which coordinate you're gonna jump in order to do a one iteration, let's say. And the way that he
Actually, the
go
the
on.
struct declaration on the Racket side, oh, not the struct declaration, the function declaration is not quite correct because we expect to get a pointer, but here it's saying we get a record instead of a pointer,
Yeah, but how
which
do you say
is
it's a
not
record of something?
a pointer to a record in this case, right?
Yeah.
Let me check here. Um,
So find and get value. Yeah, we can even check the changes in the C code. Yeah. Definitely check that.
info pointer add. Enter
Yeah, and Magenta
offset.
changed that instead of returning an int, we're returning a pointer to a record. And then you're going to iterate through memory using the schema information to know how to jump things, which is really convenient, but I really wanted this to be done in C, man. For me, it's just nonsense. Not nonsense, but extra work for no reason.
It
Uh,
would be better to do this in C because we have to walk through the tree, right? Through the tree leaves.
no, no,
And
no, we
that would
don't
be
need to do
easier.
that. You can just do, like, if the leaves are connected within themselves, this is basically a for loop iterating through the values. Like, not iterating using an index, but iterating using offsets, right?
But an offset on its own into the tree, well,
It's because from our point of view, there is no tree. There is only an array, which are the leaves at the bottom, right?
yeah.
And we know
But the
they
array is
are
not
sorted.
contiguous. Yeah, but the array is not contiguous is the issue. But well, we'll have to think about it. Okay, so apparently you have to return a pointer, and then you cast it when you actually want to use it, when you do a pointer ref.
Okay, that's cool. We actually have that option. Should we make a function in the C code and make that available? We can do that. We don't need to strictly follow Mageta's version in this case.
Um,
Yeah, because to me it would be something like extern record star star find and get values. And then you pass the root, you pass the key, and then in here there will be some sort of for loop of some sort.
some sort of for loop of some sort.
Yeah.
But then you have to return an array, right? And
Yeah,
an
this is what I'm
array.
attempting to do here.
The problem here is that we don't know the size ahead of time, which means we'll have to do a dynamic allocation, which that seems kind of messy now that I think about it.
Were you thinking that would not be messy at any point? That's amusing. Oh yeah, this is kind of it actually. This. So in this particular case, you pass the range, right, that you want to look for. But again, you need to do the things that we didn't uncover how to do it, which is how to use per arguments as return arguments, right? So you're gonna mutate those things.
Yeah.
Um, but the logic should be here. So he starts looking by for the first one. If you don't find anything, you just return 0 because this is returning if it succeeded or not. Then you do a for loop across across all the keys, I guess. Oh, this is just to put the I into position. Oh yeah, this is just to put the I into position of it. But why do you need this if you already know it is in here? Do you see the problem? That's kind of sus. Like you already
Keys.
asked, you already know that this n is a pointer to the leaf that found this key start. Why do you need to increment I to go into there? Like, isn't this already like 0? Isn't this already over in the first iteration? Because this will always be true. Like, well,
That's not even a loop, is it?
no, this is a loop, but this is a loop just to literally to mutate I. This is
For
just
I equals
changing
0.
I plus plus until it reaches this.
Oh, I see. I see. As long as I is less than the number of keys and the key is smaller than the key start, which means
Yeah, but this should be
it
the first
terminates.
one. The I should be 0 every
No,
single
no, this
time.
is finding. It's just finding the leaf. It's not actually finding where in the leaf the key that we're interested in is.
Oh, because the leaf can have multiple people in there, right?
Yes.
Okay, that's cool. So then this if seems out of place. Oh no, this is because you need to check this after you mutated I a certain number of times. That's okay. Um,
Yeah, if we stopped because the number of keys equals I, that is, if we reach the end of the leaf, then we didn't find anything. Otherwise, we did find something, in which case,
ooh, this is a double loop. Okay. So this is you're basically gonna mutate the original root of the first find leaf now, because you're gonna do this until while it's different than null. Then you're gonna keep incrementing I, and there is a thing called num found. Where is num found? Num found it starts with 0. That's fun. So you're gonna do that until you reach the key end, which is the other parameter that you passed there. And then you're gonna mutate the first return argument. You're basically gonna do that. The the position num found would be the n keys I, and the returned pointers num found n pointers I. Okay, so this is basically copying everybody, including the keys and their values, until you reach the end condition, which is the key end, and
yes.
that's kind of it. What is order, by the way? Order.
It's probably a parameter related to the maximum possible size of the tree.
Is this a global variable?
I'm guessing it is, yes.
That's bad. Order.
It's not a variable that will be mutated though. It's more like a global constant.
Okay, okay, that makes sense. Yeah, but then why not do const then? Uh, a little
Because
sus.
reasons, probably.
A little sus, but let's go on. Um, so then what you do? That's. Is this going backwards? What the heck is going on here? Ah, wait. Whoa. This is grabbing the last one. And like you grab wait. What?
Hmm. Well, for this to work, the order has to mutate, doesn't it?
No, no, no. The order doesn't have to mutate. You're always grabbing the last one out of the pointers of the current n. This is always grabbing the last one, I think. Because
Oh, right,
the
because the
middle
last
ones
one
you
is
already
either
cared.
right, because the last pointer in the node will like in the leaf, I mean,
We'll
will
point to the
either be
next
a
leaf,
pointer
right?
to the next leaf or
It,
it's gonna be null because we're at the end. I see. That's how you walk through the leaves.
but that's a little sus because what if what I'm looking for is in the middle of the leaves and there are more leaves afterwards? This while loop will only stop when you reach the end of the leaves. In that case.
That's only true if the leaves from a certain point onwards
Holy
is
man.
filled with keys that match what you're looking for.
Yeah, but they are supposed to be sorted. So if the nodes are sorted and you encounter a first one that doesn't match, none of the other ones should match, man.
No. There's that first loop that does that. And if that first loop doesn't modify the I variable to be different from like however many keys the leaf has, that means we know that there are values that match what we're looking for. So we just start collecting those until we reach one that doesn't. Like, for instance, if we're looking for the year 1999 until 2001, for instance, and there are years 2002 and up in the tree,
No, that's
that's
correct. That's correct. I understand your point, but you're not getting my point, which is that I think this is extremely inefficient because if what you're looking for is value in the middle of the B plus in the middle of the leaves of the B plus tree, this thing will go from the start until the end, checking all of the leaves from the start.
yes.
Yeah, that's bad because if they are sorted, you shouldn't have to do that.
I mean, the trade-off here is either you do a linear search until you hit the key end condition, or you have to jump to a bunch of indirections to do a second search in the tree to find where
I think I
we
disagree
don't.
with you. I think that's not a trade-off at all. I think this condition is wrong. This should be n n key and the arrow keys I is
Oh, I
less
see.
than key end.
I see. I think I get what you mean. We need there should be before we reach the end of the while loop, there should be a test if the I get it. There should be a test at some point inside of the while loop. Um, if the current value that we're looking at
Is
is
already out of
not,
bounds of this thing.
yeah, in that case we have to break out of the loop. Yes,
Yeah, exactly.
that's not.
So but that's again, this is very inefficient, but uh, only in certain scenarios because no, actually all the time. But it depends on how many leaves you have, how much more effort that's gonna be. Okay, so actually I think we're gonna. My suggestion is the following. My suggestion is the following. This code is pretty much the same, and we can just say that you do not receive anymore like any a key end like that. That's it. Then you ask for the thing in here, and also I gotta change this function there. That's cool.
Actually, the finds leaf you
And then
have
in here I
to
just say key, and that should be it.
you have to do equals equals key instead of not equals.
No, that's true.
Yeah, and in the finds leaf you have to pass the key twice because it expected the key ends, right?
Where?
Unless you plan on changing the finds leaf as well, but I don't know.
Finds. I'm lost. Where?
Find 507.
507. What's the problem in there?
You got rid of the key ends that you were passing to the finds leaf,
No,
right?
find leaf only receives one key.
Oh, I saw you delete something from there though.
I
What was
deleted
it?
this.
Ah, right, because you renamed that parameter. Okay, that's
Yeah.
fair.
Okay, and this is not going to be a find range. This is going to be a find equals. And if my understanding is correctly, we should be able to do if n keys.
That function is not external, by the way.
This function should be extern. This function is not extern. This is sus. But okay, this was already this. Okay. We should be able to do something like key and then break immediately. But I don't know if this makes sense. Do you think that makes sense?
I think it does, yes.
Yeah. Okay. Okay. So here's the deal. We didn't discover how to do this properly.
We did not actually.
We should, if we want to use this and pass the responsibility of doing the iterations to C, we gotta discover how to do that properly. So Racket
Ah,
FFI
you see,
return arguments.
the annoying thing is that um, that function presumes that the the buffer we're passing is gonna be large enough, right?
Yeah.
It's not quite ideal, I don't think, because like that means we have to know ahead of time how many values we expect to find. That seems
Not
wrong
really. We
somehow.
need to know ahead of time what is the maximum amount of values we are able to find. Because we can have fragmentation in there and pay the trade-off of putting like a, I don't know, 256 and not utilizing all of the space.
I'm not worried about that. I'm worried about it possibly being more than we expected. See?
Yeah. I understand the problem. Yeah, but the only alternative to do to that is to not do via C and do it via Racket. Do you want to do that?
Uh,
We can
I mean, we
try.
could. We can try, yeah.
Okay, so let's try. So let's put this as a comment. This should be enough then, this. And I also gonna allow the record
Uh, Actually, we
to
should
be.
probably add the what is it? Finds leaf, that function.
We need
So
find
that's our
leaf.
start. Our because that's our starting point, right?
No, because the find and get value is the starting point as far as I understood. This is the starting point.
But then we will have to. Problem is that find and get value. It doesn't.
We can try to see how
Well, I
this is
mean,
being done. So
ah,
find and get here. So the way that this works, he's just using a straight up find, apparently.
yeah, but I mean, the find range that we were looking at before, it uses find leaf as the starting point, right?
Yeah, it does. It does use that.
Uh,
What about
and
the
we kind of
find one? What this does? No, not this one. This. Finds and returns the record to which a key refers. Is this mutating the leaf?
it
Actually, the
shouldn't.
leaf. No, the key. The key doesn't matter, right? Because this is already a leaf. Um, if root different than null, leaf must have a value, even if it does not contain the desired key. The leaf holds the range of keys that would include the desired key. Oh, it also uses the find leaf. The find also uses that. Something is wrong with this indentation. Um, then he does a one-line for loop, going through all the leaves that are equal to the key that we are looking for, apparently. Um, this, it's hard to tell, but I think it is related because it's using find leaf as well, which is the function that you were mentioning.
Yeah, yeah, I think we should use that as our starting point because we'll have to walk through the leaves to find every value that matches what we want, right? do that, we have to have a leaf to start from.
Yeah, but
Otherwise we don't know, like.
no, you're right. But the find and get value calls find, and the find calls find leaf.
The problem
I,
is that it doesn't return the leaf, it returns the value.
it returns the leaf, the record that is
Oh.
contained in the leaf.
But we need the leaf if we want to iterate.
Yeah, this is the leaf, a record.
No, it's not.
Oh, this is only the value part of the record of the leaf. I'm sorry. This is only the value out of the leaf, right? So you want the leaf itself.
Yes, otherwise
Um,
how are you going to iterate and find every value that we
that's
want?
that's bad. Okay, I think you are right, but I don't want to do two searches, man, because this is sounding like I'm gonna have to do two searches. I'm gonna have to grab the leaf, do a call to the find to have the value.
No, but we will have to iterate over the values to grab all of them anyways,
No, no,
right?
no, 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 no. That's different. Before I thought that we would iterate and we already have the values there, right? We would already have the values there. In now, my understanding is that you're gonna have an array of pointers of leaves, and for each one of them, you're gonna have to call this function.
No, you don't. You just call find leaf to find the first leaf where the items that match what we want are, that match the key that we are looking for are. And then at most, we'll have to find within that leaf the first value that matches our key.
Uh, yeah, but that only is the case if the node contains the value information, which I think it doesn't. So let's check that. Okay, so what is a node? Okay,
It
we're
has some
fucked.
point.
It doesn't have it.
Why?
It doesn't have it. This does not know the record. It doesn't know. The leaf itself does not know its own value.
What do you mean?
Exactly that. We have a record. We have a record, which is the thing that we are looking for, and we are gonna do the comparisons, right? We're gonna use
Yeah.
these to do the lookups and find and grab the values out of memory and compare them with what we're looking for.
No, 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 no. The record, that's not what we are doing the lookup on, okay? We have the keys, which will change depending on what we are indexing on. So it could be a year, it could be in the name, it could be whatever.
Yeah,
The
that's one
record,
indexing. That's not what I'm talking about, but go on.
the record tells you, okay, for this key, there is an entry in the database at this chunk number, this page number, this slot within the
Yeah,
page.
do you agree that that's what we are looking for? Do you agree?
That's the value that we want to grab, yes, at the end of the day.
Yeah, so do you also
But that,
understand that the leaf does not know that?
but that's not what we are basing our search on.
No, which search? If you're talking about the B plus 3, I agree. But I'm talking about the second search, which is you grabbing this in order to go to the database and check if this is what we're looking for or not.
But we don't have to do that.
But if you don't do that, how are you going to know if this leaf is the end of the line or not? We need to do that.
Because the key that we are searching on will be in the tree.
Because the key. No, but the key is. Wait. Okay, I think I'm confused because to me the key is basically ear. No, not ear.
Well, it could be the year, could be a name, could be whatever, right?
It's gonna be 1999, right? The key, or something like that.
Yeah, sure. Let's use that as the example. We have an index based on the year, and we know that there are some entries in the database where the year is 1999, and that's what we're looking for. Yes.
Yeah, so in order to know that if this leaf is good or not, in order to be saved for you being used is in the output, in the outcome, we need to grab the record in order to go there and see, do you have 1999 or not?
We don't actually,
We don't. That's the part that I'm missing then.
because the key will be in the tree as well.
Because the key will be in the tree as well. Hmm. Okay. 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 So what you're saying is that we can basically just use this function, pass the key here, which by the way, this is an integer. Is this really the 1999?
Well,
Be-
yes, it
because now
would
that I'm
be.
thinking about it, this forbids us of using something else as the.
It does, and that's a problem. Yes.
Are you sure? Let me go to find and get value. No, that's not. That's also not what I want. Um, find and get value. Yeah, there. So here's the deal. Here's the deal. How we were using this? How were we using that? So find and get value. We grab an index. We
Which
grab an
actually will be a
index.
record of the chunk and page and offsets or slot numbers.
Yeah, in the new version, yes, but in the previous version. Okay, I'm starting to get confused. This is the thing that we are looking for, 1999.
Yes.
That sounds wrong. Oh no, but it can't be wrong because it is written in this version. The code is really clear. We have something called attribute value, which is the last thing out of a query, and a query. Yeah, this is the last thing. So this is 1999. Yes, it is. That's bad. That's bad. Um, but okay, that's a problem
Yeah,
for future
yeah,
us.
it is a problem because it's presuming that the key will be an integer, which is not the case generally.
Yeah, but and that's gonna be painful, man, because we're gonna have to make this generic or have multiple functions. So not fun, not fun. But okay. Um, yeah. Okay, so we need two functions. We need find, get, and get value, and we also need the find leaf.
Man, this almost makes me want to write a B+3 in Racket.
Well, if you do that, that's gonna be an open source contribution right away because apparently they don't have it. They don't have a B+3 implementation in Racket, and this is like 1,000, a little bit more than like 1,300 lines of code. So yeah, it is what it is, I guess.
It is what it is.
Anyway, so find leaf. Find leaf. So we also gonna want that. Um, so these are the two functions that we're gonna need. So find leaf. This actually is a function that receives a pointer, an integer, and a boolean, and returns another pointer. Perfect. Perfect. Do we need to re-implement the node as well as a C struct?
If we want to, yes, we do actually, because we will need to inspect the node structure
Yeah.
to.
Yeah, I figured. What the heck? Yeah, there. Okay, that's actually going to be interesting. So how do you model? pointers of pointers. So we have something called
Uh,
pointers, and then I have no idea how you
that's a
model that.
that's a pointer.
And we also have keys, which is pointer. We have something called a parent, which is a pointer.
We have
Uh,
something called isLeaf, which is a boolean.
is leaf. Um, oops, bool. We have
Is
num keys.
isLeaf has an extra letter.
Don't know why I'm keeping adding that. And we also have next, which is also a
A
pointer.
pointer.
You said we only cast that when we need it. We don't put them in here.
We don't, which means that pointers will probably be just a pointer as well. Isn't that a very informative type declaration?
Well, I mean, this is one of the issues that you can go into when you're doing FFI. So it is what it is. Okay, so let's now finally go back to the pagination. We have all the functions that we need. I would like to actually go from bottom up, or should we go top down? Ooh. Okay, let's first try top down, and later we can regret that decision. Uh,
You know what? You know what would be very neat?
what?
If the return value was lazy.
Why?
I don't know. I don't know. I really don't know.
It would be neat, but you don't know why. That's cool. That's software engineering, 2024. Uh, okay. So
Well,
actually,
I never called myself an engineer. So
that you're not far off. You're definitely not far off. So let's go to the build pagination function. The build pagination function receives the same amount of things, apparently. And the only thing that is changing, as far as I can tell, is that this is now a much bigger thing. Because the find and get value. Wait a moment. Wait a moment. Oh, because now the insertion already also requires these three numbers. That's interesting. And before we had a
yeah,
tree, and the tree only had a key and a value, and now it has all of these other things.
yeah, because those three things will have to be assembled into a record, which will be the value uh, associated with that key.
We have a struct, so maybe we can use that. I don't know if we should do that. That's very,
Uh,
very interesting.
I mean, the problem is that, well, problem is that if it's a racket struct, now we have to do some interop regarding the garbage collector, which sounds
Oh, he
annoying.
created something else. I see. Okay, so here's the problem. So before this was not an index array, this was an array of something else.
Okay.
And he created a new thing called index with capital I. And an index is now a chunk number, page number, slot number, an entity, which has a column map. And what the heck is a column map? A column map is a map between a string and a value. Huh. I wonder how this was before.
A column map, isn't that like a schema or something?
Yeah, it seems to be the case. This is kind of a schema. Yeah, before it was an array of tuples. Before it was an array of tuples. And now it is an array of indexes, and an index has a key and chunk number, page number, entity slot number, and an entity. And an entity has a column map. I wonder why we need the entity. I wonder why.
Mm,
Where is he using that? First of all, it's not in here. And it is also not in here. That's weird. That's really weird. Do you see the thing? Like we have, oops, entity. Yeah, there. Uh, then oh, he is using it in here. What was the in the instances before? Before it was an array of bytes.
oh,
Oh,
I see.
oh, I
I
see what
see.
he did. This is to not have to deserialize the thing twice, as he was doing before. I see, I see, I see what you're doing. Okay, I guess it makes sense then. I think we are actually doing that twice because we're dumb. So read table values from disk, read the table. Yeah, we are doing it twice. So we're gonna shield his optimization as well. Why not? Um, so let's make that. So struct index. In order to be an index, you need four things, which is the key, the columns, the chunk
You're missing an
number,
end on columns, by the way.
columns.
I feel I feel like a spell checker today.
Yeah, page number and a slot number. And then you're gonna have a guard on that. Checked guard. And then in here, the key will have to be an integer. And we should put a comment in that. This should be generic later on. Don't know how yet though, but that's okay. The columns. The columns is really interesting. So we need to make a hash map, right? We already know how to make a hash map. Hash. Not really hashable. That's not really what I want. Oh, here it is. Okay, so there is a way. You just say hash. And then everything else is basically going to be this. So there, there. Um, interesting. And then chunk number, page number, slot number. And we should grab this comment, put it in here. And this should be it for creating an index. This should be it for creating an index. So I think we should go straight up to the build pages.
You forgot to return the values, by the way.
I forgot to return the values, that's true. So let's go to index. Struct index. So after you're done with that, so you return the values. So values, key, columns, chunk number, page number, slot number.
And you're
Is
missing a
this?
list, and you're missing a list around the parameters as well.
Oh, well, yeah, that's really wrong.
Yeah, because it's a list of pairs, right? Where each pair is the parameter name and a contract or a predicate.
Oh, my extension is trying to fix the crap. Um, and then there, and then in here we can just do this. Cool. Build pages. This is the function. I really don't like this heck of ton of destructuring, but that's okay. Um, so let's go. So to build a page, uh, is this really different from before? Because I think it is, which is kind of meh. So now he's building the pages. This is really different from before. I see. So he's creating the pages now instead of creating the instances, the indexes. Do we need the instances though? Apparently we don't. This line is the same, but everything after that we don't do it anymore. I see. So in that case, what are we doing? What are we doing? Oh, we have a
Okay.
function called create indexes, which should not be here apparently. Uh, and worse, it is doing that and is returning instances. What? Oh no, this is doing a map on them. And this is doing the map with two inputs. This is doing a map with two inputs, which is something that you can do in Racket.
Yeah, that's basically like a zip with.
Yeah. So these are creating the indexes, but we don't need this anymore. We don't need this anymore because we're not gonna do that. Oh boy, this is gonna be not a very pleasant experience, I think. Because you're gonna have to remember which abstractions we mapped to which abstractions. So this is definitely creating indexes. I have no problem saying that. This is definitely doing that. But these two lines are gonna vanish out of existence, which is cool. Which is cool. Uh,
You can't write bugs if you don't write code.
so let's take a look. So what we were doing before. So we were grabbing the instances and doing an array mapi. That's what we were doing, but now we're not doing that at all. Now we're not doing that at all. Uh, question.
Yes.
He's doing two chunks by size function calls. That seems wrong. Why why is he doing that? You see this? Array chunk by size F sharp. Array chunk. Divides the input array into chunks of size of the most chunk size.
Oh, so that's basically like
That's slicing.
group by enclosure.
Are you sure? No, it is
Ah,
not.
no,
It is not.
no, I got confused. It's not group by. It's man, what's the
This
name
is
of
just
that
a
fun?
slicing, man. This is not as fancy.
No, no, it's not group by. It's there is a helper for that. I just don't remember the name. What is the name?
Split by. I don't know. Yeah, but this is still weird because he's doing that twice. You see?
Oh, yes, because first you're splitting the.
I
Oh,
didn't
hello,
see you were
Mageta.
here.
Yeah, but how does that work? Does the second array
Oh,
is
no, he
sliced?
starts with. No, yeah, he starts with bytes.
Yeah.
Then he chunks it by the size of the instance. So now you have an array of instances effectively.
Yeah.
Oh, let me update this code. Wait a sec.
Is this code wrong?
Then
No, but it's slightly more complicated than it should.
Nice.
I mean, it won't fix a lot, but it will be slightly better, I suppose.
Okay, so just push it, please.
oh, I remember now. I found it. It's partition by actually.
Oh, okay, then that's a better name.
And I changed the C function, by the way. I don't know if it's working, but
Actually, that's still not correct.
What did you change
Partition.
in the C function?
wait. Mm,
Okay, it's just partition. Yes.
push origin. Okay. Can you update?
What the heck happened there? Okay.
What the heck happened? GitHub. What? Man, why is your GitHub broken?
No, yeah, it was broken, but now it's fine.
So I made a new one called find and get node that gives
the
me
diff doesn't want to load. That's a bad sign.
oh, because I ran the formatter, so it changed everything.
Oh, okay.
But
So
search
it's.
find and get node.
Oh, I hate it. Okay.
Like
Find.
basically on the C, what I changed is everything on C now is using this record.
Oh, he's doing the thing! Marinho, look! He's doing it!
Well, yes.
We were no, but if you watch back the stream, we started by saying I really wanted to not have to do the iteration in the host language.
Oh, I am not doing in the host language.
Yeah, no, but the solution is basically this.
Yes, that's you need to put to split an array. There's no way
Yeah,
around
but
it,
how
I
did you
think.
get around the? He did it, Marinho. He did
He's
it,
calling
man.
malloc.
What's all the fuzz? Like this is just setting a vector, an
The
array.
fuzz is that Marinho said when we noticed that the solution would be a record star star, which is exactly what I proposed. Marinho said, "Yeah, but then you're gonna have to do malloc and realloc and crap. And I don't know if I want to
Yeah,
do that."
I did something kind of dumb, but it prevented me from doing a realloc, which is that might be still wrong, by the way. I didn't test, but the here's the problem there. I'm just counting on this particular instance without counting on the next. Like I'm trying to see until if you see the comparison of the four, it's going until the key that is different. You see?
Which is exactly what we were about to do.
But the problem
Exactly.
is, I don't know if this in this C garbage. Well, I won't say garbage, but in the C code, and saying garbage, that's just an insult for the guy, right? But that's not what I meant. But anyway, the 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 C code, the guy is allocating a next pointer that is a next in terms of the
Oh, so you're not
records,
going
the
through the
leaves.
leaves. Or you're only going
I'm
within
not
one
going through
leaf.
the leaves because I don't think I should.
Why?
Because it just because he has a list of pointers inside of it, so there's no reason to go to the next. I don't think that's what he intended.
I have no idea what you're talking about.
He has two things. He has a keys list and he
Yes.
has a pointers list. When we
Yes.
search, it finds a list inside of the node. So why would I go to the next node if I already found the node that has that key? There are not two nodes that have the key.
Wait,
It's
Like
what?
only
on this
true if
on
you are
this design,
sorting.
he's putting everything on the same, I think.
Oh, so your
Oh,
hypothesis is that everything that is the same
That is
key,
equal is
they
just
will be
going
in
through
the
the
same
same node.
the same node.
Yes. That's what I think at least. I didn't
Ooh.
test. I need to run
Yeah.
and
So
try.
when we were drafting it, I actually can show you. When we were drafting, we think we have a strong belief that range. Yeah, so find range. Yeah, so we think it is something like this.
What the heck, man?
This is the same thing as the find range function, but instead of providing a key end, we're not going to provide that. And the criteria will be the same as your criteria. And this thing is doing the jumps between leaves. So this is jumping to the next. Believe it or not, don't just trust me.
Right.
This is good. This is why he's doing this.
Mm-hmm.
But this is going through the leaves. This is probably a very
And then you do
similar
either
for
null
loop.
or you break if it's different than a key.
Exactly. And this is the very similar, probably very similar for loop that you did. This one.
Yeah.
So we were planning, but then we would encounter the problem of having the how to do
Return the pointer, right?
return arguments. Yeah. So we decided to just comment this out. But if have you didn't test anything about this,
I tested just a normal case just now, but I
and
didn't
it
test the
worked.
other one. It worked, yes.
Okay, so do me a favor. While we keep porting this thing to the Racket, try more examples, such as try to add two entities in a table that has the same key value, or more, two or
Let's
more.
say, like say
Oh,
index on the
it doesn't
year
need to.
and
It cannot be true, right? It needs to be like
What do you mean cannot
I
be
don't know
two?
how many because we need to read the code because the problem is if he's storing indeed all in the same, how are we gonna know that okay maybe that he has a threshold that he starts populating another node? You see,
I
we need
actually
to
don't
read.
think that's the case though, because we didn't write the original. Amos, if you show
Yeah,
show your emails
show
where
my
we're looking
image.
at the yes. Scroll up a little bit. We didn't write the original find range. That was already in the code, you see.
No,
And
Magni.
what
But Mageta's point is not that. Mageta's point is, oh, Mageta wants to know if there's a threshold. I don't.
Yeah,
Yeah,
because
there's
I
definitely not a threshold based on this code.
my problem is like he just has two lists of the same length, right? That he keeps adding things.
Yeah.
So the first list is the keys, and the second list is the pointers. And then you
Yes.
access them with the same index, so I suppose they have the same length. And
Yes.
then one is the keys, the other is the value. But why would you link the box instead of linking the members? That's the part that I found it confusing because in a B,
What can you define members in box, please?
a leaf is the entire box, right?
Yes.
Inside that box, he's storing tiny lists to store things that are equal to the key of this box
Yes.
instead of
yeah,
just storing one element per box. You see,
Yes.
yeah,
which
Yes.
I would think would be the normal B+3 thing that you see around.
Yes.
So that's why it
yeah.
makes me believe that you don't need to jump between to the next one, just in the
I
same.
don't based on this loop, which again we didn't write, it was already there. I don't think that's what's going on because
Oh,
otherwise,
but here's the thing: he's doing a range. He's not picking the same, right? So in a range, you can assume to have different. So
Oh, he's right, Marinho. It's a
mm,
different assumption, man. It's a completely
oh,
different
that's
assumption. Marinho, Mageta wants to know if they are all equal, can I be certain they will be in the
that they
same
are all
block,
in the same box,
in the
yes.
same box? But
And
in
since the
this
oh
box
function
that's
doesn't
assumes
seem,
that they are different. That's why you pass it two
and
things.
since the box just seems to be dynamic, like in size, I think you can.
right
Okay,
because it's a pointer.
Yes, and he
okay.
just keeps doing a lock all the time. So
Yeah.
I
In
don't
which
think
case we can just well, in which case if we just want to find one, uh, yeah, I see.
Yeah, I think Mageta has a point. I think Mageta has a strong point that uh, we can be certain. Well, not certain because we should test it, but we can have a little bit more confidence that everybody that is equal after balancing the B+3, everybody will be in the same node. Everybody that is. Could you test that in the simulator, Mageta?
How do I test that? Is a
You
good question.
make a random b plus tree, and then at the end you start putting the same value over and over and over. And then you're gonna see that the b plus tree rebalancing.
I think I removed the main. That's
No,
what
no, no, no,
probably.
not in the code, in the simulator that online.
Oh, right. Okay. So let me see here. Visualize data.
Okay, while you do that, we're gonna look again into the code here.
So what was the example again? Can you say it? So
Make
I
a
just had the random,
make a generic b plus tree
and
with
then I
I don't
just
know
start adding.
350, 400, blah, and then at some point you pick I don't know 425, and you start adding like 6 times in a row.
It just occurred to me, Rackets may actually have something that's, I'm not sure if it's actually implemented as a B plus 3, but it has the same semantics
That would
as
be
far as I
amusing.
can, which is actually in this library. And funnily enough, I recall that because
What the name?
part, yeah, because
Rebellion.
I'm actually listening to the Madoka Magica soundtrack right now, so Rebellion like is a word in my mind. And if you go to the multi-dict, it's basically a dictionary where you can have multiple entries with the same key.
So I
Multi-dicts.
inserted a bunch of sevens, but that's my point. Like I think the representation inside the like his representation of a b plus 3 is different than the one in the algorithm that is using to draw this thing here.
Okay, so in the GUI, in the one in the browser, it is not the ones that are the same value are not being in the same box.
Yes, they are not. They are separated by an index.
Okay,
They might still
so
be the same, but
we are
well,
I'm
okay,
just
but I still want to try it out given that I think your argument is strong. Go on, Marinho.
I'm just not sure if the multi-decks have like if the keys are sorted, because we would need that for ranges and such.
Yeah, no, but for now, let's go with Mageta's implementation. Later on, we can try to make it a Racket only. So let's see what were the changes in here. Ooh. Okay, so he ended up also having to add the leaf host implementation.
actually no, I just removed that actually. I just pushed, but
Oh, you
that
pushed a new
should
one.
do. No, I just see CR record. I mean, I pushed a new thing, but I was using that. You can just ignore it.
No, you're not using leaf.
No, I'm not.
Okay.
Let me remove that.
Um. Oh,
It's
Marshall. Okay.
C record. Yes, that I'm using.
Yeah, you're using C record, it is the same thing that we have in here. Okay, so the index is still the same, Marinho. And the page
Yes.
representation is also still the same, which is great. Wait, this is a type. Index builder, chunk number, page number, instance number, column map to an index. Who needs that?
Let me see. Okay, so
Oh,
this
it's to
index
type check
builder,
this.
yeah,
I
it's just a
see.
type, but it's an alias for a function predicate that will
Yeah.
give me the index building.
Yeah, yeah,
So
yeah, yeah, I
you
noticed.
pass it to the so it's a way to make it generic the way you build the index, if it's in a string, if it's in if it's a integer
How?
or
Oh, you're
something else.
passing that as an argument in here.
Yes.
Wait, you're passing a type as an argument. Can you do that in F sharp?
No, no, that's not a type, that's a function.
That's not a type, that's a function. Where is the
That's the
implementation
what
of
you
such
saw
function?
was what you saw 124, that's a type, but the
Yeah.
function has that type.
Oh, okay, so this is a function. Okay. I see. I see. Wait, okay, so Marinho, we gotta think on how to do that then. Okay, so mm-hmm.
Let me try
Okay.
Index
printing some.
builder.
So I think
Wait,
we're
the
gonna
index builder
I
just
think
takes the values, right,
I
from the
think this is
index
gonna have
and
to be in a
builds them.
query, man.
What? Wait.
Yeah.
Why?
Because this has everything to do with the query, no? Like, because
Oh
it,
wow.
it, it
It
depends
worked.
on the type of the thing that you were looking for. So if you're looking for an year, such which is a number, this will be an index in which the key is a number. But if you're searching for a string, in the future, this should be parametric, this type. So this should be like t index that has a t, a capital T, and the t goes here. Did you get it, Marin?
I still don't see why that should be a parameter to the query.
Because that has nothing to do with anything else aside from the query information. Only the query knows the type of the key, because the query has the attribute index to index and the attribute to value. So this is the 1999. This is the only way that you know that the type, the generic, the non-generic version that this will be. Do you agree with that?
Yes.
So that's why I'm proposing to put it in here for now, the index builder.
What?
Why
You know.
do we need an index builder in this case, though?
I think we
Uh,
do. Go on, Magitan.
I'm okay. I'm just trying to print stuff, and I can print, by the way, the C structure because of
Yeah,
the
the
conversion.
FFI.
So it is converting correctly. I just have a bug that I need to see how I deal with later. That I'm serializing like empty rows, basically. But I'll fix that. But I just have one record stored, and I can retrieve the index like just fine using the group. I mean, it's not exploding.
So
That
it
is.
worked.
Well, I guess it did, but
Try
well, I
other
can't be
examples,
sure.
man. Try other examples, like more complicated examples. I don't know. Marin, why don't we need an index builder?
I mean, we may need to use it somewhere, but we actually probably don't need it as a parameter because, like, the index builder is a function that takes all the values we need to build the index and then it returns the index, right?
Yeah.
Yeah, it
That's
returns
just
the
the
role ID
constructor
right
for,
in the SQL Server design there.
but isn't that just the constructor for the struct that we defined? Why does that have to be a parameter in a dynamic
Dynamic language.
Like my idea for that, right? Why I pass that there? Because that would be a constructor, a generic constructor for the role ID and the key, at the same time uh, that it serves as a entry point for a random kind of query. So, for example, if we need to encode the key, for example, let's say, imagine you like on the C code, you just store for now integers, right? So imagine we want to put like strings, we could probably just change strings to integers and then just handle comparisons,
How are
right,
we
with
gonna
that.
transform strings to integers?
ASCII. Oh, actually the opposite. We would have to convert integers to strings and then just to rely on ASCII to do comparison with like a string comparison,
I'm
strmp.
confused. I'm searching for the string Magetta. How does the b plus 3 with
My point
integers gonna
is,
handle
you
that?
you can have arbitrary types. Like imagine in the future, you add dates, you had strings, you
Yeah.
add whatever.
Yeah.
Then you need a generic type that you can compare. But since the code is in C to do the comparison, you can't just do a polymorphism there. That just doesn't work. So how do you
That,
do the
that
comparison?
that's a little bit. There is a way to do that. That's the thing.
You just cast to a void, and then or you can just cache everything to string and do string comparison. That's one.
Yeah, well, that's one way. The way that I would suggest is to make a void, add an extra argument for the C functions, which is going to be an enum of types, and then when you grab basically the blob of bytes, you check the type argument in the
And
with
then
the
you
switch
just
case.
shift how you compare.
Yeah, and then you
Uh,
cast to reinterpret the blob of of bytes as such.
yeah, that's a lot more work than just making work with string for now.
Yeah, but that's more generic.
Uh, It sounds like you're
It is.
re-implementing dynamic typing in C.
I am,
Yes.
because C doesn't have the capabilities to do what F sharp can do, for instance.
But, uh,
Uh, okay, I want to go back to the conversation about the index builder. So Marinho, go on. This thing that Magenta did is to allow generic index. So when the key at the point that the key is generic, how are we going to handle that in a dynamic language without passing it in here?
Um, First of all, we need a generic comparison function, which is not very hard. We just have to create another generic interface. There might be one for that already, I'm not sure. Implement it for the built-in types, so we have proper sorting, uh, and then when we build the actual index value, like we just use the constructor for the index struct because that's already dynamically typed, so it can just use the one constructor in all cases. I don't see why we need to parameterize that.
Oh, because the language is already dynamic, we can do whatever in the inner levels, right? Because I don't know if you noticed, but Magenta is passing this around. Uh, actually, the more I see to this code, this is like just a state mode all over the place. There's a bunch of parameters that they keep going deeper and deeper and deeper in the recursion call.
well, that's just bad design. That's not even.
So here's the index builder again, but in this time in the build pagination, and the index builder is passed again to the build pages function. And the build page functions, it uses it in here. But we can already do that in a dynamic language. You don't have to keep to pass the generic type over and over. Is that what you're saying?
Yes, that is what
Okay.
I'm saying.
Okay, so I am convinced. Good. So in that case, by the way, Magita, I also noticed that even though this code is better for sure, you are not looping over the chunks yet, and we should do that.
No, but you don't need to this point. Well, I mean, you
You
okay?
only
Yes,
need to
we
loop
need,
over the
but
chunks to
now it's
build the
trivial.
tree.
Yeah, that's
Yeah,
trivial,
but
but
now
we
it's
should remember.
mm,
We should remember.
yeah, because now you got everything you need to access, so it's easy. You just do a loop and that's it.
Yeah. Okay, so the build pagination doesn't have a change because we're not going to pass the index builder. Uh, okay, he changed to a more testable sample. That's nice.
Yeah.
Uh, we also did that. We also did that. And he also changed a number 1 to a number 0. Did we do that in our version? Build pages.
Uh,
Okay, this is kind of sad.
yeah, I
What?
start on the chunk 0 actually, not on chunk 1. That's why.
Oh, this is because the first chunk that you're going.
The amount of parameters I pass there is
Yeah,
obscene.
yeah. We don't have chunk number, by the way. Maybe we should update the tailor now.
Chunk-
Marinho, are you there?
Yeah, maybe we should.
Chunk
By the
number.
way, what is the thing that I said this is sad is because I was looking at that Rebellion library that I linked. It has multi-dictionaries, and it has sorted maps, but it doesn't have sorted multi-dictionaries.
Cool. Cool, bruh. Oh, we also should do a thing. Where is it? Here. Uh, okay, so the default tailor needs a chunk size, instance per page. Okay, so before the false, 0. And we're gonna start from the chunk 0. The default page byte size, default chunk size, and then this. Okay, this is where the 0 needs to go actually. There, default chunk size. I'm gonna also chunk. This is not default, this is initial, and this is gonna be 0. initial chunk size. Okay, the tailor is updated, so now it also has track of the chunk number. So then we don't have to pass it as an argument.
We also need the page number and the slot number.
Okay, that's true. Let's add to our measurement master the other stuff.
If we're going to take a chunk number, page number, and slot number, why don't we just take an index? Doesn't that contain the same information?
If
It
you're going
contains
to
more.
repeat things,
It contains
Why
more
do we
money.
have the key and columns in the index, by the way, Mageta?
Because this
wait, I
is a
wasn't paying
trick that he
attention. What
did
is it?
to. Yeah, I can explain some of it. So the columns is because he wants to not have to deserialize twice. That's for sure.
Yeah,
And
and
the
this
key
already deserializing, so I just use it.
was already there in the other version. The key
Which,
needs to
by the
be in the
way, I
index.
think I am doing something bad because man, there's no way it's gonna deserialize everything all the time. Like you do a search, that's really bad. I don't
Yeah, no,
think
we
it does
should
that.
cache it. We should cache it, but that's a different
I don't know
conversation.
if you need. Here's the point. I think this like caching is a solution, yes, but I don't think like a normal DBMS does that. Like just caching and it's fine.
Well, if by caching you mean serializing the index, then yes, they do, right?
No, you can also do that if you want, but I was referring to a more aggressive way. So I use it as a search. You save the results of that in memory to some time for some time, and then if another search comes in, you try to reutilize what is already on memory instead of going to the disk and doing all the process again. I'm sure they do something like that. Okay, but going back to the question, so why do we need these three numbers? Why is it different than an index? Because the index needs this information. It needs the key. We always had to have the key, but before it was a pair of integers, and the key is an integer, and the value was an integer, so that's why a pair of integers. But right now we need more stuff. That's why we are creating an index. We can though, which is maybe it's a suggestion. We can do this row ID, boom, 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 and then that, and then that, and use that down here. Oops. There, and then there,
Oh yeah.
row ID. What do you think about that, Maria?
Uh, key columns, row ID.
And then we can
And then
we
the
can
row
just use it
ID,
here.
I see.
Row ID, row ID.
Yeah,
Vinicius is
that
here.
yeah, that seems better. That seems better.
Cool. I should give proper credits. Thanks SQL server. Uh,
Proper credits.
yeah. So initial row ID. And this is going to be row ID 000.
Oh, apparently there is actually a sorted multi-dictionary. It's just called something else. It's called an association list.
Weird. Okay, the tailor knows how to measure it, which is cool. It's going to keep track of that for us. So then we don't have to. We don't have to. Wait. This is the index of the first of the chunk that you're going to look for, Mageta.
Let me see. What?
This zero here.
This is the
Is it?
first chunk.
Yes,
Is the
but
chunk number.
yeah, but that's. Wait a second.
I'm not looping. So
Yeah,
it's just the first
okay,
chunk.
you're not looping. Okay. But you would have to loop it in here. Okay.
It
Then
is evaporated.
let's see what happens. So build pages. So it's apparently the same thing as before, aside from having an index builder and the chunk number right now. But we have the tailor, so everything is already. We just need to, unfortunately. And I still want this structuring, Marinho. Still want that. So tailor there. Tailor row ID tailor, and then in here I'm gonna extract row ID chunk number like that, like so. And then we're gonna do page number, and then
Oh.
slot number, and then this is page, this is slot. Okay, we're ready. He changed here as well to 28. That's okay. Let me see the rest of the code, please. Thank you very much. Yeah, it is the same as before, but now he's not creating any indexes and instances. He's creating pages up front. So now let's go back to this question, Marinho. So the first time you have a stream of bytes. You chunk that via the instance size. So you're basically gonna have you're
An array
gonna
of instances,
an array
still
of instances.
serialized.
Yeah. And then after you do the second chunk by size, you're gonna have what?
An array of pages of
I see.
instances.
I see. Okay, let's do that. Let's actually do that. So we're gonna have to create an
Yes.
extra function called create pages now, because we're not gonna create indexes anymore like that.
And I did find the closure function that's equivalent to that. It's called partition.
What do we need to do this thing? We need the instancers,
There's the partition here, too, but it's actually different. Something weird.
instance size. We also need the instances per page. Do we have it? Yes, we have instances per page. And for now, that's only it. I'm not gonna add stuff that I don't know what is for. And then what we're gonna do? We're gonna. Oh, we also need the buffer. Okay, see. Uh,
Ah, man, I cannot convert an array dynamically using Marshall. And guess what? I will not find any docs on this. I'll have to guess.
you're gonna make the docs and produce blog posts. That's it.
For something that probably no one cares because C
No,
Sharp is what, from
somebody
2002?
cares. That's for sure.
Oh, then people know magically because the language is from like 2000s and yet there's nothing documented.
I'm pretty sure people know it, but nobody bothered to make a blog post about it.
Ah,
Um, okay, so we need the buffer as well. Uh, okay, I think because we have this saved, I'm gonna actually just nuke this. And then let's go. So what is the Racket function? This is the question now. What is the Racket function to do exactly that? I bet there's none, and we're gonna have to create ourselves. Marinho, your bet?
I'm actually searching for it.
I think there's none. Absolutely no.
oh man, this is
Folder.
so painful. Oh man. And I
Okay,
need to call manually the garbage collector. You gotta be kidding me.
wow, that's a lot of effort for F sharp. Find
It's actually
def.
.NET that can't manage this. It's just a dynamic reference, so it kind of makes sense.
Okay, additional list functions. So in F sharp looks pretty neat, so I hope we can mimic that, Marinho.
Goodbye. This is not it. Um, In combinations,
Split
shuffle.
at. That's not what I want, but is it split at that didn't exist in Okemo or something like
I don't know. Some they don't have a lot of stuff that is useless because
that?
apparently you should type yourself all the time or just rely on a library, right? To just use the to improve your utils, and they are proud of that apparently.
Yeah. No, they are proud of the first part. You should do everything yourself.
Yeah, you can't be proud of their build system or anything.
Allegedly. Partition? Oh,
No.
but no, but partition takes a function. Ah,
Oh, yeah, because partition is just splitting, right? It's like a split. It's the
Yeah,
same in
with
F
the
sharp.
yeah, partitioning Racket takes a predicate and it returns two lists. One contains only the values that match the predicates, and the other contains only the ones
okay, so
that
here's the
don't.
deal. If we don't find the function, this is a straight up something I'm gonna make as a open source contribution. This is ridiculous. Like people complain about it, but it's true. Haskell has it all. Fuck. Clojure has it. F Sharp has this one as well. But
Which
man, what the
function you
heck?
want?
The chunk by size one.
Oh, like to split. Yeah, that's a very useful thing.
No, I think the answer will be that nobody should be using lists because they are slow.
Well, nobody should be using linked lists because they are not suited for this. That's true.
Okay, but does vector has it? If
It might
vector has it,
actually.
I'm fine.
Let's see. Data types, vectors.
If the list
Uh,
doesn't have it, I have very low expectations about the vector.
I don't know why they're not. I mean, I understand the vector like then having some differences, but in like ML, for example, all of them share at least a base, and they extend as needed. Like I don't know why it's not the same. Like you have the same operators under the same name for the different types, like that are collectibles.
you kind of have that naming convention in Scheme. It's just that for lists and vectors specifically, um, first
Man,
of
they
all, in
have.
default Scheme, in standard Scheme, they are both mutable. And lists are actually a derived concept. What you actually have is a pair where the second element is either another pair or null. Um, Whereas a vector is basically an array.
Mm-hmm.
Man, they have split at right, but they don't have some sort of like uniform splitting. There is also a third option, Marin, which is to go straight up with bytes, man. Because the buffer is a bunch of bytes at this moment, so theoretically speaking, if the bytes has it, we are fine.
I mean, we could use ranges for that.
Ah, not a fan. Is this it? Okay. Uh,
Do you want to see the implementation
of what?
of F sharp?
The chunk by size?
Yeah, it's there on the GitHub.
Where?
Uh, wait, we just need to find, but it's here. I'll send here. We just need to go to the primitives, basically. Chunk by size on the primitives basic list. Can I
Okay,
jump
what
there?
if I search for chunk in here?
Chunk by. There's one there.
Chunk by. Wait, you saw there?
I saw there chunk by.
Chunk by. This is. Wait.
Huh?
Oh, it's almost, man. But it's not
Oh,
with a
it's not. It's a
length.
predicate.
It
It's
is a
chunk.
function.
Oh, but look, chunks off. That's what you need. Chunks
Oh,
off.
chunks off. Yeah, but then there's a thing. This is always the same as Haskell's. Is this a third-party library? Yeah.
Oh man, you're gonna have to download. Oh man, no. That's. I'm sorry, no, that's too much. Just do it yourself, man. Here it is. I got the code.
Ah, so freaking sad.
So this is the implementation that is on
Oh,
the
how useful.
FU. No, no, it's here. It's just a reference because it's generic, right?
Yeah, but where is this? What is this
I just sent
namespace?
here.
No. Oh, this is it?
Yeah.
Okay, let's take a look. No, screw it. I'm gonna just throw it in here.
And it's safe because if it doesn't have one extra thing to complete a chunk, it just completes with the remainder. Like just that.
Okay.
Oh, I think I remember why that function is um, because like that actually requires us a loop, right? You need to keep some state so you can assemble the first chunk and then you continue with the next one and then like
I don't understand what you're talking about.
And it's
It's
like a
just tail
fold,
call.
right?
It is just yeah, it is a
Yeah,
fold with tail call.
yeah, tail call.
That's it. Uh, arg.
Don't know why they're not using tail call. They're fresh cons, no tail
Yeah, you're
call.
gonna
I've
have to
never
grab
seen
that
that.
for me. You're gonna have to grab that for me.
I've never seen that. Oh, but you know what you do? Like you just fold with a state, right? You just split the remainder and call it again.
by the
Uh,
way, if you use append, I'm gonna slap you.
oh, I will. I can already tell you that I will.
Literally me with the
Uh,
entire code with append on Erlang. Appending on the head, which is
no, no, no.
I
I'm
written
gonna
it
use
here.
cons in this case.
Yeah,
Marinho already told me that I should do that. Okay, so the accumulator is the second. So this is like a list of lists,
cons.
and this is an element. Uh, ooh.
Because you cannot
Okay,
append
actually,
here.
Mageta, you actually need two things. Is that how you do that, Marinho? Or you need to do something like this?
And no, the cons was actually correct before. I mean,
Oh,
that works as well. It's just that in the previous case, you were pairing the two functions. Yeah, no, that's wrong. You should.
yeah,
The second will fail, right? Because it's not a list.
yeah.
No,
So
you don't need to
we
put
need
the
two.
first
No,
in the
we need
list.
two things. That's the thing. Because we need the inner accumulator of the split and the accumulator of the entire thing. Uh, so then, yeah, here. So then we do a let, and then we say, so this is the current list, and this is like
But I
first
don't know
of,
why I look at the syntax on Scheme and I kind of get a little
and this is the general
distressed. I don't know what
list.
it is though. It's very minimal, the change from like bloat common Lisp, right? But I
Yeah.
get very, I
Okay.
don't know, uncomfortable.
And with that,
That's probably something
then we
to
do
do with.
if. Go
I
on.
wonder if that's related to the uncanny valley.
To what? Sorry.
The uncanny valley phenomenon.
Okay, what is that about?
It's you know when you see something that looks like a person but not quite, you feel uncomfortable.
No, not really. What's how do you type that?
Like this.
So uncanny. Oh right, right. So it's like a it's like an AI face, right? Something like that.
I forgot Marinho. So you do cons and then the head of the new thing, right? And then the accumulator, is that it?
Well, you're taking the length of the current list inside of the reducing function. That hurts me.
You need to do that though. If you don't want to go with crazy optimizations making the accumulator bloated, you need to do that. Like you can enhance this with like an integer of some sort or something like 0 and then use that to count. But that's optimizations, we can deal with that later. So then we do this. Wait. Oh no, we don't need to do it like that because you already have this thing destructured. So it's gonna be a list in here and general. Ooh. Okay, so it's cons and then element with the wait. No, it's something in here and then general list in here. And then this is cons element current list and this is just list. This. And this is if it's equal. If it's not equal, then we do uh, cons element current, and I forgot a thing. Okay, and then current list, and then general list. Does that make sense, Mari?
I guess you'll probably need to reverse the chunk before you.
Oh, this is because you're not using append, right?
It's still more efficient to build up the list backwards and reverse at the end instead of doing appends repeatedly.
Really?
Yes, because append is linear on the size of the list on the left.
So how? What's the name of the function? Reverse?
Yes, it is reverse. You also need to reverse the chunks that you use to build the what's it called? Somehow I feel like this would be actually better to implement as instead of doing a fold L, doing a fold R, deal with the fact that this is not a tail call, a tail recursive loop, and just accept that you build a deep stack potentially.
So doing a fold R in here. Doing a fold R. Okay, so does the argument change? How useful? V and L.
Value and
And
well,
list?
I suppose it's the element. Oh, I don't know actually. I thought it was
It's the
pretty
value in
clear.
the list.
But list is the accumulator then, right?
Is the
In
list
this
the
case, yes.
And
Yeah, yeah.
why
It is.
not call it like ACC, man? Like,
Yeah,
what's
yeah,
the
the
problem?
names are bad. But I can appreciate not swapping these between fold R and fold L. Cool. So then we don't have to reverse it anymore, right?
We shouldn't, but now the accumulator has to be built a little bit differently, I think.
Why?
Let's see. On one side, you'll have the list that you're building, and on the other side, you'll have the current chunk, right?
Yeah.
So if the current list has the same length as the chunk size,
That means that we need to reset the internal accumulator and just put the current one in the general one. And then we could, because
that's enough. That's off by one, by the way.
I have no idea what you mean.
If the length of the current list is equal to the chunk size, that means the current chunk is already full, right?
Yeah.
So why are you adding another element when it's
Oh,
already
it's
full?
already full.
So what you actually have to do is this. You do cons list with just the elements on the left side. No, inside of the lambda.
Yeah,
Inside of the
I
lambda.
know what you're talking about, but let me do a thing. Uh, because I'm bothered by your comment. So this is current counter, and this is gonna be car, and this is current list. Okay. Okay, repeat please. Uh, -1, right?
Okay, if the current, okay. No, that's okay. So if the current, if the current counter is equal to the chunk size,
This is still wrong
why?
because we should not add a new element.
Right, if the current counter is equal to the chunk size,
You just returned this.
you have to reverse the current list and cons it into the general list.
No, it's so. Oh yeah, you're right. You're right. You're right. Oops. So I'm gonna. You said I have to reverse it.
The current list only, not the entire thing.
And
And
cons that
then
into the
on,
general list.
yes, and then ah, cons 0 and then list uh, of elements on the left side for the true case of the if.
Oh, but then this is wrong. This should be 1.
Yes, it should.
That's weird. Do you agree with that? Do you know what we are doing? This is really unnatural to me.
It kind of is. We should really
We
do
should
that thing
subtract
in the.
this thing. We should like subtract.
No, no, no. What we really should do is
Here.
check if the current counter -1. Yes, that's.
Yeah.
Then we do the cons onto
Yeah,
the.
but you saw that, right? That we were doing a very uh, unintuitive, counterintuitive logic there.
You need some parens around that list, otherwise you're putting a function there.
Yeah.
And
Um,
then reverse, and then we still have to cons the elements onto the current list, right?
yeah.
Do we though? Because we're traversing it from right to left. Actually, I don't think we do need to reverse it.
Yeah, I think you're right. We are doing from right to left. I think we are fine. Oh, this is much better. Holy crap. Uh, if that's not the case, that means that we can go on. That means that we can go on. And
We cons
effectively, that means that we need to do
current counter +1.
counter.
You can replace the +1 with just add 1. There's a function called add 1 that adds 1 to a number. It's very convenient.
I get it. So this is the
Yes,
first
and
thing, and this
then
is the that. Go on.
yes, and then after the fold R, oh, but then we run into another problem
Ah.
because if there's a chunk that's smaller than the rest, we want that to be at the end, right?
Yes. Hmm.
Ooh.
Which is what the F sharp function does.
Ooh boy. Okay, maybe using recursion is better then instead of a fold. What do you think, Marinho?
Yeah, that would be my first instinct as well.
Like this really sounds like we should use recursion because if doing fold L we have some trade-offs and fold R we have to treat it later. Ah, so annoying. So we need something like an inner function here. Um, yeah, which is going to be the function. So I don't know, inner chunk by size, and this is going to have extra arguments such as the current counter For now, I'm also going to put the current list and the general list in there. And let's go. So the first thing that we need to try is this equal here. We need to try that. There.
I think it's possible to do it as a fault R, but we would have to rethink the entire logic. Yeah.
No, it is definitely possible, but I don't think. I think readability is kind of like really getting affected. Uh, ooh. Okay, so actually before this if, there needs to be another if though. There needs to be the if of the case that we just discussed.
Yeah.
We need to do that. Yeah, because these are the same. These things are the same thing. But before that, we need to do the check if we are already out of elements. Right? Isn't that the problem that we just had?
Yeah.
So I think we
Uh,
gotta do that. So how are we gonna do that?
okay. Here's the idea. We have n, which is the chunk size that we want, right? And then we decrement it when we go into the recursive case. And whenever it
Wait.
reaches 0, we reset it to the original size.
Wait, repeat that. I was thinking about a second alternative and I got lost. Can you repeat, please?
Like if the current counter, okay, we start with the chunk size, which will be a positive integer, right?
Yeah.
And then if it's not 0, that means that we are building up a chunk.
Yes.
And if it is 0, that means we have to add a chunk to the output, and then okay, I think I have an idea, but I don't know how to express it
Okay,
very
I
well.
think listen to my idea. I think I got something. Maybe it's less smart than yours, but it works. So my idea, which is grug, is to have two extra counters. Actually, not two extra counters, but one constant and one counter. So this would be like a total counter and max size. And then before doing anything else, you're gonna check if two things are
Man,
happening.
can't you just copy the function I wrote? I did exactly that.
We don't have chunk by size to fresh con stale, man.
No, man, you're not getting it. I did a tail call with the same thing.
I'm
Like, let me
confused. Are
pick
you
it up
talking about
here.
this code here?
No.
No. Okay.
Where's the... Oh, I'm looking at the wrong code. Do you have the code there?
Which one?
The one you're looking with the index. Look for the deserialize function.
Mm,
That, it's there.
there?
Yeah,
Where?
but don't look at the diff, right? Otherwise you're gonna...
No, yeah, but where?
The diff you
Where?
can see, it's on the deserialize.
Here.
Deserialize. Yeah, this reconstruct columns. That's the same thing. You just
Um,
change the... Yes,
I
this.
have a feeling it's gonna be pretty similar, but let's take a look. So, he's still using the function thing in there. Okay.
Yeah,
So what he's doing is the following. So he checks if there is a single and no more elements, only one element remaining. Oh, this is so much better with pattern matching. Holy crap.
So if there's only one, it's just accumulator. If there's only oh sorry, if there's zero, it's just accumulator. If there's only one, then it should be a tuple, which is my thing that I do a uh, I add it to the accumulator, and then that's it. If there is more, there is one and the rest. Then I pick the return. I call a function again, Oh, sorry. No, I just slice the
Yeah, but you're gonna call the
the
function again.
byte string. Yeah, we can do a function to slice, right? And then I just slice based on the intervals I want. I append it to the ACC, and then I just call again reconstruct columns, which is the recursive call with that return, passing the remainder, and that's it.
This does exactly chunk by size in the behavior that the last one will be potentially missing the chunk size count.
Yes.
Okay,
I mean,
so
the only unsafe part is the function on calling, right? But that's the from bytes. But that's my problem. Like, if you just do a const, then there's nothing unsafe there.
okay, let's try. I think we should try that money to gain time. So I think I want to do some sort of a cond or a case.
Don't you have like a PKs on Racket?
B case.
Like in Lisp, you have PKs, which is literally pattern matching.
B
Well, Racket has a
B
match.
case.
Oh, it does.
Mixing patterns and expressions. That's not it.
Oh, that's no. You have
Pattern
Rackets,
pattern matching.
dude. Dude, there's literally a match macro. It comes with the standard library. Uh,
Yeah, it is this
you
one.
have to.
Oh, man, why are you not using that then?
We
Look,
don't
there's
know.
even a when.
No, because the cons in ML languages they can be used in pattern matching. And we don't know if that's the case with the pattern matching in Racket.
It is actually.
Well, if it is, then we are just uneducated. List arg. Okay, so how do I do it then?
Actually, even if it wasn't, which it might not be, you can just use a dotted pair and it does the same thing. But it
Use
totally
what?
can use cons, so that works.
Okay, so I can say things like uh, list empty. How do I pattern match an empty list?
I think it's the when, right? Or just a list without anything, right?
Yeah, you can just do a list without anything. That works.
Like this?
Yeah, yeah, like that.
I
I
see.
think.
Okay, so do. We don't have a guard.
By the way, man, you should really learn the smart parents. I learned, and it's amazing to type something like Lisp and the rest.
Smart parents.
Yeah,
Oh, do
like
you mean the extension to use the shortcut to?
yeah, like to handle the parentheses for you.
Oh, I use that at work.
Like I just learned how to use this. I just learned the slurp forward and barf forward, and to walk over expressions and flip them. That's already a huge difference.
Personally, I like to use parinfer, but that's just me.
Wait, do I need a do block? Is this creating a function only in the scope of this match?
Yes.
That looks like it
Wow.
to me.
Wow, bro.
But you don't
That's
need
not
the do
really
just
that
to return a
impressive,
value.
but
Yeah, that is impressive to me because we have a guard, which is Haskell F sharp. We don't have this,
well,
and this
it's just a
sounds
mod.
really useful.
I mean, yes, it is, but well, why would you have that in like Haskell? You're gonna just start the scope and define it anyway.
No. This allows you to have the same name of a function in all the pattern matching branches, but they have different behavior. That's awesome.
Well, that's I don't see how that's different from just having the same definition on different
It's
patterns.
literally just sugar for a let, basically.
Yeah,
I guess the one thing that's difficult to match to replicate in Haskell would be that you can put that before a guard.
before a guard. Before. Uh,
Yes.
what? Can you give an example? I don't.
Actually, the documentation that Lemos was looking at has an example where it has a pattern and then it says do define sum to whatever, and then when the sum is less than six,
Hmm.
see.
Um, okay, so I don't know. Head, rest. Uh, tail. Okay. And then I need to do when
Does
there.
that really do what you want it to do?
I have no idea. I am experimenting with this right now.
Because it's doing like list ABC, you see? I think it's like literal positional.
Yeah, but if that's the case,
Maybe combs instead of a list, try combs because then the second
oh,
of the end.
like
Yeah.
this.
Yeah, you need a cons. You do.
I
You need
see.
a cons.
Uh, okay, so when empty tail. Mhm. What should I do? I should do a cons of something in ACC.
That already improved the legibility of the code substantially.
um, wait. Magetta is producing a pair. Do we need that? I don't think so.
No, probably.
What do we need is... Wait a second. This is not considering the chunk size at all, man.
Yes, because it's not a chunk by size, it's another. I'm just saying the structure is the same. You're just gonna do an if on the other thing to see if you already have the last element you're looking at in the. I think it depends if you're gonna pin reverse or not. You're gonna look if the head
Oh,
or
but
the
we're gonna...
last
Yeah, but I
is
thought
if
it would
already
be a one-to-one.
sized.
It is not a one-to-one thing.
No, it's not. You're gonna check if the size is the same, and then if it is the same, then you just it's the same as what you want, right? To chunk by. If it's the same, then you just continue appending on it. Otherwise, you create a new thing and append everything on the front. You see?
Yeah, but...
That's the only difference.
Yeah, that the difference sucks.
It's
Okay.
just a win, man.
No, that's not a win.
Yeah, it's
So
just
there needs
it's
to be
an
an end
if.
here. We need to check if the length of this head, which is a list again, this is a list of lists, what we're building. So the head is a list. We need to check if this is less than the chunk size. Because if it is,
You're
that
already
means...
splitting. What?
Yeah,
You
so...
already. It's the length of the head, and then you just say, is that the same as the chunk size? No. Then do whatever. It's just an if. Why are you putting that in a guard? Oh, okay.
Oh,
You can separate into patterns if you
yeah,
want
yeah,
to
yeah,
make
but
it clear.
it would be the same pattern. I think that would not be ideal then. How do I put in the when? Oh, it's parentheses. Okay, that makes sense. So it's not this. Okay, then we need to do the if that Magetta said. So if the chunk size is equal to the length of the head, um, that means that we need to create a new one alone. Is that right? Yeah, that's right. We need to create a new one alone of this guy. Okay. Uh, so in that case, it's going to be list. Uh, wait. Oh man, this new code is confusing. This new way to think. Wait. We have only one element left in the total argument, in the total list or byte stream or whatever. We have only one. What we want to know is, should we create a new sublist for this guy, or should we add to the previous
First
one?
of all, do you have an element? You assume that the tail would have it, right? That you're sorry. You're
I'm assuming that
you're
the head
splitting.
has an element, yes.
So this list arg is the accumulator, right? In this case. No, it is not.
It is not.
Okay, so you're splitting the other one. Okay. So you should check the length of the not the head, right, but the accumulator. The head of the accumulator.
The head.
Actually both. Yeah, you need to check both lengths because if you still have elements on the list to split, right? And if you have the proper length on the accumulator to put in there. You see?
Yeah. But that's sounding more complicated than the recursive version, the older recursive version. Oh boy.
Oh, that's just an extra thing on the if, and then you just append, or you do the cons, whatever you're doing there.
Yeah, no, but here's the deal. The accumulator, uh, we need to grab, we need to add stuff at the end of the accumulator, right?
Hmm.
We need to do that. So using this strategy will require a reversed, or we do append. Do you agree?
Yes.
Okay. Um, you said to check for the length of who?
So I'll
But
describe the algorithm. Marinho typed something. I think he did
He
actually.
did it, right?
Yeah. But the approach would be like uh, you have the accumulator and the list. You need to go removing from the list and adding to the accumulator, right?
Yes.
What's the condition for you to do that? You still have elements in the list. It's still not empty that you
Yes.
already hopefully eliminated on the first pattern.
Yes.
And on the second, you would just see, okay, is this last element or the beginning? Like, I don't know which one you would be picking. I think the cons would pick the last you added, right?
This,
So
you mean
is
this cons?
the head, yes. But here's the thing: it's not that cons. You need to cons the ACC. You see?
Yes, yes, yes. I see, I see, I see, I
So you
see.
would cons the accumulator, and then if the accumulator says, okay, the head of it is still with like 2, but the chunk by size is 3, and we still have one element, so just push, like cons this list of the head with another guy, and then boom, you have another one. You see?
Yeah. Marinho did imperatively, which
But then
is
I think
no,
if you're
it's not.
consing,
yeah, it is
if you're
imperatively. You use a let loop.
No, it's recursive. Just
No, it
it's
is
not
a a,
imperative.
a loop with a counter and everything. So yeah,
which
it
is
is
not which
definitely
is
a
not
loop with a
imperative.
counter.
But
uh, but it's fine. Uh,
yeah,
so
the
what Marinho?
problem with the other cons, man, is that it everything would be reverse, and then
Yes.
even the minor lists, like you would have to still convert all of them. That's pain.
Yeah. So let's see the other way Marinho did. So he created a let loop calling recur on giving a in a what's the name of that, man? Giving a resemblance of closure. Then he has the elements in the chunk. I'm assuming the chunk is the current chunk,
Yes.
and he is gonna do a for loop backwards.
No, actually.
It is not the for loop backwards. Wait, original n. Original
Yes,
n.
because we need to remember that. I should have named it something like chunk size or
Yeah,
something,
yeah.
but
That name, that
hindsight.
name was like what?
Yeah, because
Uh,
I just called it n over there, and then I realized halfway through that, oh, we actually need to keep the original value of n, so let's call it original n.
so chunk size. Okay. So he did a con checking if the element is empty. If it is empty, he checks if the chunk is empty. He checks if the chunk is empty.
Yes.
Yeah, makes sense. Otherwise, you can't put anything there.
Oh, so we're gonna have to reverse it. Okay. If n is zero, if n is zero, that means that we finish the chunk. So
Yes.
again, reverse again, and call the function again with the next element. Else, that means that it is not zero. We're gonna call the function again, update the counter for the which chunk, inner chunk we are, how many are remaining, I guess. And in here, we are grabbing the first out of the elements, putting that in the chunk. Wait, we are grabbing the first. Why do we need to reverse 2 times then?
We only reverse it once, actually.
No, we reverse twice, here and here.
But those are different cases.
No, I know they are different, but I'm asking why do we need to reverse if we are following the natural order of the elements list?
Because we are consing it onto a chunk backwards.
Oh, that's why. That's why. That makes sense. Okay, in that
By the
case,
way, that
go.
function does absolutely no error checking whatsoever.
In regards to what?
Uh, the chunk size at the very least, it's not checking that
Oh,
it's a
it's not checking
positive
if it's an.
integer,
Yeah, it should. But you can do that with a
and
contract anyway. Who cares?
it's not checking that the elements is actually a list. So
Oh, that's
there's
actually
that as
something that
well.
I want to tweak. Can we make this work with bytes and not lists?
No, because this function presumes that we can split the value into a head and a tail using
And we
car
cannot do
includer.
that with byte strings.
We could, but then we would have to reallocate a lot, which would be very expensive.
I'm underwhelmed. I guess it's fine. Okay, so we're gonna have to do a thing, you know, right? Yeah. So in here, we're gonna have to do a threading, starting with buffer. Then it goes to do in Racket threading. Do we need parentheses? I don't remember.
You only need it if you need to pass additional arguments.
No, no, I'm fine. So bytes list. Then in here I will have two. So chunk by size. Is the yes the number? Yeah, this is nice. This is already prepared for threading. That's cool. So instance size and there, and then chunk by size instances per page there. Do we need to put? I think we can do this. We should be able to.
Doesn't it pass the argument on the first parameter if you don't specify it explicitly?
Oh, it passes as the first argument, so I need to put it in here. Yeah, but that's an argument to just change this then, right? Just put elements in
Uh, the
first?
reason the reason I didn't is because traditionally list functions take the list as the final argument.
Oh, okay, so the... But it's so inconvenient, man. For this type of use cases, we're using threadings and stuff. You need to always put this. Inconvenient, but okay. Okay, so I don't know how many minutes to pass the three lines, these three lines. But well, we didn't have the function, and we were discussing how to implement that. So next up, we do an array mapi, and this is going to be the page number of that. So we need a let loop of some sort. Is this the best way to do it though? Using a let loop? Don't you have anything close to mapi? Oh, we do! We do a map using the range.
That would require us to traverse the list like 3 times.
That would require us to traverse the
Three
list
times.
3 times. I can
Well,
only
at
count
least
one.
twice, actually. Actually,
Oh,
why?
you're
Because
counting the first one to split it? The first one?
no. You need to know the length of the list, and
Ah,
that's a
that's true.
linear operation.
Oh, do we do? Uh, do we care though? That much about that?
You could use a for list. That's an option.
For list. Have I used
I'm
that?
not sure if that's called for list or if there's another name. Oh yeah, it is for list.
Iterations and comprehensions.
I wonder if just a for can do the thing.
Oh, here it is. Oh, wait. No, but how does it grab the length of it though?
You don't. You can
Oh, you
just keep a
don't.
range.
It's a straight up.
You can just
Yeah. Wait, but how do I
uh,
say that? How do I say that it starts from zero and goes on and on and on? Because in here it
uh
seems to me that it's defining a range. Well, not a range,
let's see.
like options.
Slice, break, final. I'm pretty sure there's a way
We can use with
to
vectors, with
count.
hashes. What the fuck is this?
That's that's Racket's very extensive collection of list comprehension macros.
Iterates like for, but when last expression of body produces a value other than false, then iteration terminates, and the result of the for or expression is the same single value. If the body is never evaluated, then the result of the for or expression is false. What in the balls is this?
That's that weird syntactic sugar that I mentioned way back about, doing a fake infix syntax using dots.
But what is this doing? What is the? How do I read that?
It's checking if any element in that list is less than 3.
Wow. Okay, I guess. Yeah, that's very extensive. They have sum, they have product. They can do for with many lists. That's cool. A for fold. That's a lot of fours, man. That's a lot of
Yep.
fours. Okay, but did you manage to find it? Do we have it?
I'm actually still looking for it.
Okay, I'm gonna finish the
Let's
recording
see.
because I think it's pretty clear what we're gonna have to finish. So